Modular arithmetic. What do you mean by modulus? Mod operator or modulus operator. Modulus reminder. Okay. So this plays, with the help of only the reminder. So before to that, you must know about divisibility. Division is a very very simple mathematical operation, arithmetic operation we can say. Okay. So let us start from division itself, right? So we take two numbers. Let us take P and Q. P and Q. Okay. So we try to see P divides Q. If the remainder is 0, we say that P is divided by Q. Divisibility on this number is divisible by Q. P is divisible by Q. There is no remainder. Suppose there are some reminders 1, 2, 3, 4 or something like that. So that remainder even will be used for some mathematical operation. So whenever we perform division, we will have two things. One is quotient, other one is remainder. If the number is divisible by some other number, okay, the remainder will be 0. If the remainder is some other number apart from or other than 0, so that is where the mod operator is used to find out the remainder value. If you are very sure that the number is divisible by some other number, that is P is divisible by Q, obviously the remainder will be 0. So we are not bothered about that. So here, when the number is not divisible by Q and if it is producing a remainder, how we are going to perform or how we are going to find out and how we are going to use that in cryptography. So modular arithmetic is one of the mathematical concepts we will be using it. Like you are studying lot of mathematics, right? From your first semester you are learning mathematics. Why? Why you need to learn mathematics in engineering? Being an IT students, why you have to learn mathematics here? It has got lot of applications on your own field. So here cryptography is one of the subjects where lot of mathematical concepts are used. So mainly discrete mathematics. Like if we go on some other chapters and all, you can realize that more of your discrete mathematics will be used. So the main application of one of the mathematics is cryptography. Okay, right. So let us see modular arithmetic. Please note down the definition and then we will proceed. If A is an integer, and n is a positive integer, we define A mod n. We define A mod n to be the remainder when A is divided by n. A mod n to be the remainder when A is divided by n. The integer n is called modulus. The integer n is called the modulus. So this can be written as, I repeat again, A is any integer and n is any positive integer. So here A mod n is called a remainder where A is divided by n. So here n is called the modulus. N, whatever you are using here is called modulus. Okay, so this can be expressed as the equation A is equal to Q into n plus R, where 0 is less than or equal to R, less than n, and Q is A divided by n. Q is A divided by n. So this again can be written as A is equal to Q is replaced by A by n into n plus this R is nothing but A mod n. Or as a reminder, right? I hope you understand this. A mod n is nothing but the reminder. Normally, in any of the division, this is the case. Your quotient into the number plus the remainder will be the actual number. Okay? So, example 11 mod 7. By seeing this itself, you can say 11 mod 7 is equal to 5. 11 mod 7 is equal to 4. How? Reminder. So 11 divided by 7. So one time it goes, the remainder is 4 and that will be the mod value. So 11 mod 7 is equal to 4. This is easy, right? I give another question. Minus 11 mod 7. Who will answer this? 3. Super. How? How you get this 3? Minus 11 mod 7 is equal to 3. The answer is right. But how? Sorry? 7 2s are 14. Okay. So when you are adding and at that time, so here you must get the value as 0. Okay, 0. So if I add which number to that, I will be getting here 0. So if I add 3 over here, minus 3 over here, it will become minus 14. Minus 14 mod 7 will be 0. So that value should be written here. So this side it is minus 3, when it goes on the right side it will become plus 3. So the answer will be 3. You have to work more mod value, like mod operation you need to practice. So when it is positive, if it is a bigger number, it will be easy. Suppose if the question is like this, 4 mod 7. What will be the answer? 4. Yeah. Because when it is less than this value, we write this number as it is. Correct? When it is greater than this value, you perform division, the remainder will be written as a mod value. When it is negative, you have to see that the mod value should be 0. Okay, to get mod value as 0, which number to be added over here, you have to find out. Okay, so since here it is minus 11, if I add minus 3 with that, it will become minus 14. Minus 14 mod 7 will become 0. That minus 3 will go to the right side, it will become plus 3. That will be the answer. Okay, understood the procedure? Shall I give one more value now? Okay, before to that, take down the definition for even congruent. Two integers A and B are said to be A and B are said to be congruent. Said to be congruent modulo n. Congruent modulo n. Congruent modulo n if A mod n is equal to B mod n. If A mod n is equal to B mod n. So we say A and B are congruent. When we can say A and B are said to be congruent modulo n. If A mod n is equal to B mod n, then I can say A and B are congruent n. Okay, suppose A mod n I am getting 4 and B mod n also I am getting 4, then I can say A and B are modulo mod, A and B are congruent mod n, same n value. Clear? Say A mod n is equal to some 5, B mod n is equal to some 5, then I can say A and B are congruent modulo n, same n value must be there. Okay? Right. So now I will give you an example. Yeah, this can be written as mod congruent can be written as, see the representation, A congruent B mod n. A congruent, 3 lines will be there. Okay? A is congruent to B mod n. The symbols are very important, basic. Please try to understand clearly. 73 is congruent to 4 mod 23. Example. 73 is congruent to 4 mod 23. Correct? So how do you find out whether it is correct or not? To check whether this is correct or wrong, how do you check? 73 mod 23 and 4 mod 23. So this is very simple. I can easily find out 4 mod 23 is equal to 4. So obviously on the left hand side, I must make sure that 73 mod 23 must be 4. If that is the case, only I can write like this. 73 is congruent to 4 mod 23. On both the sides, when I perform mod with the same n value, I should get same value. Then instead of writing equal to, I can write it as congruent. Understood? So 73 is congruent to mod 23. Can you write one more congruent like this? Can you make your own left side value, right side value as well as mod value? So that is example for positive value, even for negative value. 21 is congruent to 9 mod 10. Do you agree this? 21 is congruent to minus 9 mod 10. I'll show you that whether it is congruent or not, you need to check it. Okay, how do I check 21 mod 10? Right? I don't put the symbol over here. Unless and otherwise I get same value, I'll not be able to put this symbol. So left hand side I am performing mod 10 on 21. Similarly, right hand side I am doing minus 9 mod 10. Minus 9 mod 10. Clear? So you have to find out this value as well as this value. 21 mod 10 is 1. Here it is minus 9 mod 10. So I must add minus 1 over here. So correct? So minus 10 mod 10 it will be. Since I am adding minus 1 on the left hand side, when I take it to the right side, it will become positive 1. So both the sides I am getting 1. So confidently I can put the congruent symbol. Clear? So 21 is congruent to minus 9 mod 10. If you are asking me question, is it only minus 9? No. There are so many variable values. Okay, but the condition is that left side if it producing 1, right side also it should be 1 on the same mod n. Then I can say it is congruent. This is what is about congruence. Note that, make a note, if A is equal to, if A is congruent to 0 mod n, then n divided by A, then n divided by A, which means it doesn't produce any remainder. Okay, there is no mod value. Mod value is 0. So n is fully divisible by A. The meaning is that this is one of the property. Take note few other properties of congruence. Properties of congruences. So when you know the properties of congruences only, we will be able to apply for our mathematical calculations. We will be using it in RSA algorithm, even in some other algorithms too. Properties of congruences. First one, A is congruent to B mod n if n divides A minus B. n is divided by A minus B. When I can say A is congruent to B modulo n when n is divided by A minus B, this condition is satisfied. I can write like this. Property 2, second property. A is congruent to B mod n implies that B is congruent to A mod n because both of them will be producing same value. So I can write like this. When I say A is congruent to B mod n, I can say B is congruent to A because somewhere we will be changing left to right, right to left, and then we may have to apply some other algorithm. Property 3, third property. A is congruent to B mod n. A is congruent to B mod n and B is congruent to C mod n. B is congruent to C mod n implies that anybody knows A is congruent implies right here implies A is congruent to C mod n. A is congruent to C mod n. Vice versa also we can write C is congruent to A mod n. These are the three very important properties about congruences. Shall we see one example for each of them? Yeah. So please check the first property. I will give one example. 23 is congruent to 8 mod 5. So this is the example. We will check one by one all the three properties. Okay. So first property says that 8 is congruent to B mod n if n divided by A minus B. Can you please apply and see what is n here? It is 5. And A is 23, B is 8. Yes, it works out. So here n is equal to 5, A is equal to 23 and B is equal to 8. So what I have said, n divided by A minus B. So 5 divided by 15 minus, sorry 23. 23 minus 8. Tappa kodra. 1 by 3. So I get some fraction. Correct? Second, I'll give one more example. Minus 11 is congruent to 5 mod 8. Check for this. Check for this. This division and all you don't have to Okay. So it is 15, which is a multiple of 5. That itself is enough. Okay. For this, and check the second property. Second property. Can you write A is congruent to B mod n as B is congruent to A mod n? Are you able to write? When you change the place and apply the same, are you able to get it? Suppose this I am writing it as 8 is congruent to 23 mod 5. 8 is congruent to 23 mod 5. So 8 mod 5 is 3. 23 mod 5 is again 3. So I can write, so the second property goes correctly. What about third property? So A is congruent to B mod n and B is congruent to C mod n. Then I can write A is congruent to C mod n. So we have taken 23 is congruent to 8 mod 5. So here A is equal to 23 and B is equal to 8. Similarly, you need to take one more complement where the mod value will be 3. In such a way you will have to take it. Okay. So what we have written, A is congruent to B, B is congruent to C, which means you can take 8 is congruent to some other value you have to take. Let us assume it is 13 mod 5. Correct? So here C is equal to 13. Property 3 says that when A is congruent to B mod n, B is congruent to C mod n, I can write A is congruent to C mod n, which means 23 is congruent to 13 mod 5. If I know this property, somewhere I can use it. This point is clear? So here 23 is congruent to 8 mod 5. That is one equation. Another one, 8 is congruent to 13 mod 5. A is equal to 23, B is equal to 8 and C is equal to 13. Okay. So when these two are possible, I can write this one. 23 is congruent to 13 mod 5. Yeah, please do for this. Same way I want you to check all the three properties. Minus 7 is congruent to 5 mod 8. For that, I want you to check all the three properties. Once we are clear with this, we can move on to modular arithmetic operations. Please complete that. So, simply mod is like this only. Finding out the remainder. Whenever it is a negative only, you should be a little careful to find out the value. Okay? And how to find out the congruent left as well as right, the mod value should be same. That's it. So that is base. By using that, we are going to perform some arithmetic operation. Okay? So modular arithmetic operations. Modular arithmetic operations. Take down. Modular arithmetic operations or arithmetic operations can be performed on arithmetic operations can be performed on modulars. So this modular arithmetic operation exhibits some properties. Using those properties only we will be performing operations. Those properties are, please note down, modular arithmetic operations properties. 1. A mod n plus B mod n like this, you will simplify in this manner. A mod n plus b mod n whole mod n is equal to a plus b mod n. Obviously, subtraction also will be there in the same way. So a mod n minus b mod n whole mod n is equal to a minus b mod n. Third property, obviously multiplication, but division will not happen in this way, correct? So a mod n into b mod n whole mod n is equal to a into b mod n. Shall we demonstrate each property? We take expression, we take the value for each. A mod n plus b mod n mod n is equal to a plus b mod n. I will do only for one operator. I want you to repeat for the other operations. Simplification and all is not required. Okay. So in your book, I think to demonstrate that property, they would have taken expressions and solved, simplified that much and all they won't ask, because this is not a mathematics subject. Okay, so we are using those mathematical concepts for the cryptography, so you must know to apply it. But sometimes in 2 marks they may ask you to write the property. Okay, some people, if they want to twist the question or deviate from the cryptography, they may ask you to show this expression or giving some expression and simplifying, but the theorem based simplification is not required. Okay, fine. So 11 mod 8 is equal to 3, 15 mod 8 is equal to 7. 11 mod 8 is equal to 3, 15 mod 8 is equal to 7. This is our modular expressions I have taken. So we are going to perform addition on this. 11 mod 8 plus 15 mod 8 correct? Okay. So this will be 11 plus 15 mod 8, 26 mod 8, which is equal to 26 mod 8 is 2. So this is the answer I have found out from the left hand side. On the right hand side, here I am having 3, here I am having 7. Correct? So 3 plus 7 mod 8 is equal to 2. So my property is right. I can use it. I have taken 2 different modular arithmetic expressions, and I know the value of this. 11 mod 8 is 3. Okay, and 15 mod 8 is 7. I want to add these 2 expressions. Okay, since the values are given over here, I will be able to easily verify. If not, I need to perform add only these 2 things. I don't know the value of this. I am not given the value of this. Say here it is a very small value. It is easy for you to find out. But in the actual algorithm, we don't take these small values and all. 2 very big prime numbers we will be taking for any of the encryption algorithm. If it is RSA algorithm, select P and Q, where P and Q are the prime numbers. Always for the algorithm, we take very lengthy prime numbers. We take prime numbers, co-prime numbers, and in that case, it is not that easy. Just by seeing you cannot get the value. And in that, even if you are performing arithmetic operation, how we can do for that only. These are all the samples. Okay, when I add these two, so in a simple manner I will have to add and to check my answer is right or wrong, and even verify with the right hand side answer. So property one is verified. Like that I want you to verify the other two properties too. Make it fast. Make it fast and do. Shall we proceed further? Completed? Please do complete even for multiplication. All these things you know already, but still we are recollecting everything. That's it. Exponentiation, please make a note of it. Exponentiation is performed by repeated multiplication. By repeated multiplication. Do you agree this? Yes. Exponentiation is performed by repeated multiplication as in arithmetic operation. Modular also in the same way. Like if it is 2 to the power 5. How do we do this? 2 into 2 into 2 into 2 into 2. Correct? 5 times we multiply 2. This is the normal exponentiation evaluation. Okay. In the same way only, even in the modular arithmetic also we will be doing it. I'll show you how to find 11 to the power 7 mod 13. 11 to the power 7 mod 13. How do we do this? So we take the very simple order and then we proceed. So 11 square, that we know it is nothing but 121 mod 13. 120. So every way mod proceeds. Okay. So I want to evaluate 11 to the power 7 mod 13. Directly I want to evaluate. So I take the smaller order and then I proceed. Okay. I know don't use calculator. 11 to the power 2 is 121 mod 13. You can do it manually and tell me how many 13s will go in this and what will be the mod value here. your RSA algorithm or different key exchange, everything will be like this only. Exponentiation will be there, and on that you need to perform modular arithmetic. So the next simplest thing I have taken 11, because I know the value of 11 square, which is nothing but 4. So 4 square mod 13. So 4 square is 16 mod 13, which will be is a complement of 3 mod 13. 3 correct? Can I say like that or not? You are able to follow this? You know, I want to find out 11 to the power 7. Directly I cannot find out. Okay, so you have to depend on the calculator, and sometimes your calculator will not support you for the mod operation. Better please learn how to simplify this. So 11 square, we know the value of it. 11 square is 121. For that I am finding the mod, which is nothing but 4. Which is nothing but 4. So with that I go to the next level, 11 to the power 4, which is nothing but 11 square to the power 2. So I know the value for 11 square, which is only 4. So 4 square is the easy for me. So 16 mod 13, which will be 3. This is for 11 to the power 4. 11 to the power 4. Okay. So when I go 11 to the power 4, the next level would be directly I can go for 11 to the power 7. How? 11 to the power 7 is equal to 11 to the power 2, 11 to the power 4, 11 to the power 1. Do you agree this? Yes. So what normally we do? Base will be as it is, only the orders will be added. So I will get this as 11 to the power 7. I have the value for 11 to the power 2, which is nothing but it is 4. And I have the value for 11 to the power 4, which is nothing but 3. And I know the value of 11 to the power 1, it is only 11. So on all that you are going to apply mod value. Okay, so you take as it is 11, or here itself it can be mod operator. 11 mod 13. 11 mod 13. Or simplify this and then apply mod. This is easy one, you know. 4 3s are 12. 12 into 11, 132. So 132 mod 13 minutes. Yeah. 132 mod 13. Easy only, no? See, everything I have written. So 11 to the power 1 is taken as it is. Multiply all, perform mod. You get the value as? Inama? 2. Yes, you are right. So it will be 2. So this could be written as 2 mod 13. Okay? Or you are writing it as a complement. If that is the case, let us also get it. It is equivalent to 2 mod 13. Clear? This is one sample only. You are going to use, or you are going to evaluate a lot of other exponentiation. You need to have practice on it. Next comes to arithmetic modulo sum number. You would have seen in the table arithmetic modulo, plus modulo, multiplication modulo, identity value, something and all we find out using the table. Forgot everything? Okay, we'll see one by one. Okay, arithmetic modulo 8 we are going to see. Arithmetic modulo 8. Arithmetic includes addition, subtraction, multiplication. All those things we are going to find out now. First I am going to see addition modulo I think slowly you get a number. நம்மளா போட்ட ஞாபகம் ஏதாவது இருக்கா? So if it is arithmetic modulo 88 should not come. Whenever it is 8 mod 8, it will become 0. So only the possibilities for the mod values are 0 to 7. So for row as well as column I have given. So fill that table 0, 1, 2, 3, 4, 5, 6, 7. Next would be, can you complete this table? 3, 4, 5, 6, 7, 0, 1. பார்த்தமானீங்களா இல்லையா? 4, 5, 6, 7, 0, 1, 2. 5, 6, 7, 0, 1, 2, 3. 6, 7, 0, 1, 2, 3, 4. 7, 0, 1, 2, 3, 4. 5, 0, 1, 2, 3, 4, 5, 6. Fill the table and give it. See now, when you are adding 1 with 0, mod 8, the answer will be 1. 1 plus 0 mod 8 is equal to 1. 1 plus 7 mod 8 is equal to 1 plus 7 mod 8 is equal to 1 plus 7 mod 8 is equal to 0. So 1 plus 7 mod 8 is equal to 0. So this table will give you all the values. Okay, using the table, whenever we want to perform, this is called plus. This table is made by add modulo 8. I can say addition mod 8. This is only for addition. Same table cannot be used for multiplication or subtraction. Okay, this is for only addition. Any number you can take and get the value from the table. Suppose I want to add 5. 5 plus 5 mod 8 is equal to 2. 5 plus 5 is 10. 10 mod 8 is equal to 2. Clear? So you can check with any other values. Now I have taught you how it is add modulo, addition modulo 8. I want you to construct a table for multiplication modulo 8. Multiplication modulo 8. Do it. Multiplication modulo 8. Same rows and columns, only the values will be changed. This is completed. Addition table is done. Okay. So again draw the table for the multiplication mod 8. I can give you look here. So obviously the first row will be 0 because we are multiplying 0 with any number will become 0. Similarly here column value is 0. 0 with any number will become 0. Here when you see this 0 to 7 on all the rows you will get it in some or the other places. Whereas in the multiplication it may not be possible. Somewhere some values may be repeated, somewhere some values may not be present. Okay, so start doing it.